You ever get that feeling like you're stuck in a loop, just doing the same task over and over again? Well, in programming, that's not a bug. It's actually a feature. Today, we're going to dive into one of the most powerful tools a programmer has in their toolbox: repetition structures, or as pretty much everyone calls them, loops.
So why do we even need these things? Well, imagine for a second you're writing a program to calculate sales commissions. You could code it for one salesperson, right? And then you could just copy and paste that same block of code for every other person on the team. Seems easy, but that simple little shortcut, it spirals into a massive problem, and fast.
For every single new salesperson, you'd have to duplicate the exact same chunk of code. If you have 10 salespeople, you're repeating it 10 times. 100 salespeople, your code just becomes this bloated, unmanageable monster.
And this is what that duplicated code actually looks like. Each one of these blocks uses the input command to ask the user to type something in. And that float command you see, that just turns their text into a number the computer can actually do math with. Then it calculates the commission and spits out the result. It works, but it's incredibly clunky and honestly a total nightmare to maintain.
Yeah, this whole copy-paste approach has some pretty major drawbacks. First, your program gets huge and really hard to read. It takes forever to write, and the worst part, if you find a bug, you have to hunt down every single copy of that code and fix it in every single place. Ugh. Clearly there has to be a better way.
And of course there is. This is where the repetition structure, or loop, comes in to save the day. It is such an elegant solution that lets us write the code just once and then tell the computer, hey, repeat this as many times as we need. The definition itself is really simple but incredibly powerful. A loop is just a structure that makes a set of statements run over and over and over again. It is, without a doubt, a programmer's best friend for handling any kind of repetitive task.
Okay, so loops generally fall into two main categories. First, you've got your condition-controlled loops, which keep running as long as a certain condition is true. Then you have count-controlled loops, which run for a specific set number of times. Let's start by looking at that first type, the condition-controlled one.
Now, the condition-controlled loop in a language like Python is called the while loop, and its logic is super intuitive. It's all right there in the name.
Seriously, the name tells you everything you need to know. While a certain condition is true, the code inside that loop will just keep on executing. It's a simple idea, but it's an incredibly flexible tool for controlling how your program flows.
A while loop is what we call a pretest loop because of how it works. First, it tests a condition. If that condition turns out to be true, it executes the block of code inside. Then it goes right back to the top and tests the condition all over again. This cycle just repeats and repeats until the condition finally becomes false, and at that point, the loop stops.
Here's a great way to think about it in the real world. Imagine a program that's monitoring a big chemical vat. You could program it so that while the temperature is above a safe limit, the program keeps telling a technician to make an adjustment. It just keeps checking and repeating that instruction until the condition, the temperature being too high, is no longer true.
Okay, a quick word of warning though. If the condition for a while loop never becomes false, you get what's called an infinite loop. The program basically gets stuck, repeating forever, or at least until you force it to quit. It's a classic programming mistake, so watch out for it.
But what if you know ahead of time exactly how many times you need to do something? Like 5 times or 100 times. Well, for that, we turn to our second major type of loop, the count-controlled for loop.
The for loop is specifically designed to work with a sequence of items, maybe like a list of numbers or a list of names. It just goes through the sequence one item at a time and runs its code for each one. Think about your music playlist. A for loop is perfect for playing each song in that list, one after the other. A very common partner for the for loop is the range function. See, instead of you having to create a whole list of numbers by hand, you can just use range 5, and boom, it instantly generates a sequence of 5 numbers for you, 0, 1, 2, 3, and 4. The loop then just processes each of these numbers one by one, kind of like a machine processing items on a conveyor belt. Check this out. This entire table of numbers and their squares was generated with just one simple for loop. The loop iterated through the numbers 1 to 5, and for each number, it calculated the square and printed out a nice new row. It's just a perfect example of clean, simple, and really powerful code. So we know how to repeat things, but loops can do so much more than just print some text or do simple math. They actually give our programs some serious superpowers for solving all kinds of practical, real-world problems. You've probably heard this classic programming phrase before.
It means if you put bad data into a program, you're going to get bad results out of it. A computer will happily calculate a salary for someone who supposedly worked negative 40 hours. So, how do we prevent that?
The answer is something called input validation, and we use a loop to check the user's input. If it's invalid, like say a negative number for hours worked, the loop just keeps asking them for the correct input over and over again until it gets something valid. It's almost like having a bouncer for your data.
Another superpower is calculating a running total. Think about the subtotal in your online shopping cart. For that, we use a special kind of variable called an accumulator. With each new item you add, the loop just adds its price to this running total. And the process is really straightforward. First, and this is a crucial first step, you set up that accumulator variable and start it at 0. Then, inside your loop, you read the next number and you just add it to the accumulator. The loop repeats this, and that total just keeps growing with each pass until all the numbers have been added up.
All right, finally, let's just get a glimpse of a more advanced technique: nested loops. This is simply a loop inside of another loop. Now, for every single pass of the outer loop, the inner loop has to run all the way to completion. It's kind of like the gears of a clock, and this simple mechanism can create some surprisingly complex results.
For example, take a look at this triangular pattern of asterisks. It was created with just 2 nested for loops. The outer loop is controlling the rows, and the inner loop controls how many asterisks get printed in that particular row. It's a really beautiful demonstration of how simple rules can create complex patterns. And it's the same basic logic a game engine uses to draw pixels on your screen row by row.
From processing every single frame in a video to calculating every transaction in your bank account, loops are the silent workhorses of the digital world. So the next time you're scrolling through a social media feed or you see a weather forecast update on your phone, just think about the simple, repeating logic that's making it all possible. What other everyday digital tasks do you think are being powered by them right now?